Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today is the 25th lecture of Discrete Structures CSC 102. Today we are going to start counting rules. In the previous lecture we have finished mathematical induction, in which we have studied principle of mathematical induction, and we have proved different properties, for example divisibility property, inequality and sequence property, and further we have discussed some examples, and at the end we have discussed strong mathematical induction. So in counting rule, today we are going to start the counting rules. First of all, we will see what is basically counting rules and where we can use these rules. Then we shall study multiplication rule and some of the examples. Then we shall see what is permutation and some examples related to the permutations. And at the end we shall prove an important property of the permutation, which is P of n r. So where we can use counting rules, or what kind of counting rules we shall study in this lecture. For example, we have two teams A and B, and they have to play a game. What is the winning rule? Who wins? They have to play each other repeatedly until one wins two games in a row. Means दो टीमें हैं, वो आपस में कोई गेम खेल रही हैं, तो विनर कौन होगा? जब एक टीम दो दफ़ा लगातार वो गेम जीतेगी, या और टोटल ऑफ 3 गेम्स, या अल्टरनेटिवली वो टोटल ऑफ 3 गेमें जीत जाती हैं, या रो में मींस कंसेक्टिवली 2 गेमें लगातार जीतती हैं. So how to tackle such type of problem? There is one way in which this tournament can be played is for A to win the first game, B to win the second game, and A to win the third game and 4th games. Note this, for example, this is how the both teams play a game. Then we denote this sequence of games and this sequence of winning of games like this. A means A, B played a game, A wins, we write A dash. In second game B wins, so we write B here. In third game A wins, and 4th game A wins. Here you can see that in total of 4 games, 3 games the team A has won. So the team A is a winner of this tournament. If we see the other way, the team A has won 2 games in a row, therefore here also the team A also wins. So the question is, how many ways can the tournament be played? Means कितने तरीकों से हम ये tournament अरेंज करवा सकते हैं, या ये दोनों टीमें खेल सकती हैं, so that कि minimum number of games हम कितनी ये दोनों टीमें खेलें such that कि कोई एक टीम जीत जाए, या maximum number of games कितनी ये दोनों टीम्स खेलें इस टूर्नामेंट में और उन दोनों में से कोई एक टीम जीत जाए. So the possible ways for the tournament to be played are represented by the distinct path from root. The starting point of the tournament is called root or the start, and leave the terminal point where one of the two teams is winner. Then we stop that tournament there. In a tree, the label on each branching point indicates the label on each branching point. I'll show you a graph in which the starting point is called root and the terminal point is called leaf, in which there are some branches, and we indicate the winner of the game by the branches. Now the notation in the diagram in the parenthesis indicates the winner of the tournament. We'll see a figure here now. For example, in this figure we'll discuss all the possibilities how a tournament can be played. We'll see all the possibilities. So here we start. Here we played the first match. Here we have the first match between the team A and B. First match has been played. There are only two possibilities, either A wins or team B wins. So here this we have marked here two branches, in which the first possibility is that A wins, the second possibility is B wins. Now these are basically the winner of the first game, this column. Now in the second game we have four possibilities. In the first game A wins. Okay, now in the second game we have two possibilities related to A. In the second game either A wins or B wins. So if A wins here, the second game, then A is the winner of the tournament. Here in the bracket, in the parenthesis, this means that A is the winner of the tournament, because the condition is that here, which we have mentioned in the problem, that team A and B are to play each other repeatedly until one wins 2 games in a row or a total of 3 games. So here the condition has been fulfilled for the winner of the tournament, that A has won the consecutive 2 games here. So A is the winner of tournament if these are the possibilities, if these are the cases. If the first game A wins, second game A wins. Now if the second game B wins, what happens? Then nobody has won the tournament, because in one game A is the winner, in the second game B is the winner. So here nobody still wins a tournament. Now we see the second possibility of the starting point. Here we have same results here. If B wins here the first game, then in the second game there are two possibilities. Again, in the second game either A wins or B wins. If B wins the second game here, then B wins the tournament, because B has won the 2 consecutive games. B जो है लगातार 2 गेमें जीत गया है, तो B is the winner of the tournament. If this is not the case, then suppose A is the winner, then here we arrived here, then we don't have any result of the tournament, because in first game B is the winner and in the second game A is the winner. So now we move further. If we suppose that in the first possibility A is not the winner, B is the winner, then we continue the tournament, because if we suppose that A is the winner, then this tournament stops here, because A has won 2 consecutive games. So A is the winner of the tournament. Because we are here considering all possible outcomes of the tournament, therefore we study here all possibilities. So we suppose here B wins the second game. In this possibility, if in game 1 A is the winner and in game 2 B is the winner. Now they played the third game. In third game there are two possibilities, either A wins or B wins. If B wins here the third game, then B has won the 2 consecutive games, and according to the first possibility, first criteria of this problem, that either of two will win the tournament if they won the 2 consecutive games. So B has won here 2 consecutive games, so here the tournament stops, because B is the winner because B has won the 2 consecutive games. If this is not the case, B is not the winner, then A will be the winner of the tournament. Oh sorry, A is the winner of the game 3. So yet the winner has not been decided because A has won here 1 game, second game B is the winner, in third game A is the winner. So there are 2 wins of A still until here, until this game 3, because there is another condition of the winner in the problem that until one wins 2 games in a row, consecutive 2 games, or a total of 3 games. अगर कोई भी टीम लगातार 2 गेम्स जीत जाती है तो टूर्नामेंट की विनर होगी, या कोई भी टीम अगर टोटल ऑफ 3 गेमें अगर ये ज़रूरी नहीं है कि वो लगातार हों, इन ए रो हों, 3 गेमें अगर कोई भी टीम 5 में से 3, 4 में से 3 या 3 में से 3 जीत जाती है तो वो उस टूर्नामेंट की विनर होगी. सो स्टिल हेयर no condition of the winner has been fulfilled here, because A wins first game, B wins second game, A wins third game. Here we suppose, so A has won the 2 games out of 3 games and B is the winner of only 1 game until here, until the 3rd game. Now we move further. Both teams played a 4th game in which there are again 2 possibilities. Either in the 4th game A is the winner or B is the winner. If A is the winner here, then the team A has won the 2 consecutive games and therefore A is the winner of the tournament, because team A has won the 2 consecutive games. If this is not the case, then B is the winner. If B is the winner, then until here, until the 4th game, A has won the 1st and 3rd game, B has won 2nd and 4th game. So none of the teams has won 3 games out of 4 games. So none of the teams are the winner of the tournament. So we will move further. Then if B has, suppose that B has won this game and they played the 5th game, then there are again 2 possibilities. Either A is the winner or B is the winner. Now here, until the 5th game, if B is the winner, then B has won the 2 consecutive games here and B is the winner of the tournament. Now if A is the winner, then in the series of 5 games here, A has won the 1st game, A has won the 3rd game, A has won the 5th game. So A has won 3 games out of 5 games. So A is the winner of the tournament. And if B is the winner here, then B has won the 2 consecutive games here. B is the winner of the tournament. If this is not the case, then we can again verify the second condition, that out of these 5 games, B has won the 2nd game, B has won the 4th game, B has won the 5th game. So B has won the 3 games out of 5 games. So in this case also B is the winner. So until the 5th game, so till here 5th game, either A must be the winner or B must be the winner of the tournament. We cannot move further here, because the 2 conditions of the given problem are fulfilling here until the 5th game. The first condition is they play repeatedly until one wins 2 games in a row consecutively, or a total of 3 games. So both the conditions are being fulfilled here until the 5th games. So both teams must play at the most 5 games to decide a winner of the tournament, or both teams must play at least 2 games to decide the winner of the tournament, because in two games, if A wins in first and second game, then A is the winner of the tournament because A has won the two consecutive games. If not, then they'll play at most 5 games to decide a winner of the tournament. So this we have discussed only the above case here, if A is the winner of the first game. Same process will apply on the second possibility here, if B is the winner of the first game. If B is the winner, then they will play the second game. In second game there are two possibilities, either A is winner of the game or B is the winner of the game. If B is the winner, then the tournament stops here. B is decided to be the winner of this tournament. If A is the winner, then they play the third game. If A wins the third game, then A is the winner because A has won in a row 2 games. Then the tournament stops here. We do not move further. If B wins, then we move further. They play another game. If A wins, we can move further, because until here A has won the second and fourth games. They don't win the 3 games out of 4 games. So if B wins here, then the decision has been made, B is the winner. If not, we'll move further until the 5th game to decide the winner of the tournament. So such type of problems in which we have to give all the possibilities of any problem. These type of problems basically comes in the countings. We'll see systematically how to find all the possibilities, how to find and discuss the possibilities of a problem in the rules of countings. Another example, this is basically outcome of the tournament. I have explained you all, but here on the slide I have given all the possibilities which can have this tournament. The fact that there are 10 paths from the root of the tree to its leaves shows that there are 10 possible ways for the tournament to be played. They are given by this. The first possibility is the first 2 games A wins. The second possibility, this is basically the first possibility which I have told you this. There is a second possibility, A, B, A, means A is the winner of first game, A is the winner of third and fourth game. So tournament stops here because A has won 2 consecutive games here, and also A has won 3 games out of 4. So all the possibilities are mentioned here which are possible for a team to win this tournament. So we consider another example here of which we say the multiplication rule. I shall give you the definition of multiplication rule after this example, but to understand what is basically the multiplication rule, first we discuss this example. Consider the following example. Suppose a computer installation has 4 input-output units, A, B, C and D, and 3 central processing units, X, Y and Z. So this is very easy example for you because it is related to computer science. So we have 4 input-output units which we have to install with the central processing units, CPU, X, Y and Z. Any input-output unit can be paired with any central processing unit. Means we can install A, B, C, D, any input-output unit with the any central processing units X, Y and Z. So how many ways are there to pair an input-output unit with a central processing unit? Means हम जो है input-output जो है central unit अगर CPU यूनिट के साथ हम अटैच करते हैं या इंस्टॉल करते हैं तो कितनी पॉसिबिलिटीज़ हैं. वी हैव टू कैलकुलेट दैट these possibilities. So we have to work a little bit systematically, you can say. So first we divide this problem of solving. Choose first the input output unit. So how many are the input output units? We have 4 input output units, so we can choose either of A, B, C or D. And then in the second step we have to choose the central processing unit. We'll see the possibilities with the help of a figure here. Here we say this is the start. This is basically the root of this diagram, and the endpoints are leaves. So in start there are 4 possibilities, because we can choose either of 4 input output units, either A, either B, C or D. And then A can be installed with the any of the central processing unit X, Y or Z. So further there are 3 possibilities. A can be installed with X, A can be installed with Y, A can be installed with Z. Similarly, in the second case, B can be installed with X, Y or Z. C can be installed with X, Y or Z. D can be installed with X, Y or Z. So these are all possibilities which we can obtain for installing A, B, C, D with the CPU X, Y and Z. So if we, according to the multiplication rule, if we want to find all the possibilities, how many possibilities are there, so that we can install an input output unit with the central processing unit. So the multiplication rules says us that as there are 4 possibilities here of the input output unit, and further there are 3 possibilities with each input output unit. So we can interpret it as 4 into 3, because 4 is the number of input output units, and with each input output unit we have the 3 possibilities. So, or we can say that with the first input output there are again 3 possibilities, with the second we have 3 possibilities, with the third we have 3, with the fourth we have 3, or we can say that 4 into 3, which is 12. So there are 12 possibilities in which we can install an input output unit A, B, C, D with the central processing unit X, Y or Z. So this is how we can proceed with the help of multiplication rule to find all the possible outputs of the possibilities, or this basically, this diagram is called possibility tree. This diagram is called possibility tree because in this diagram we show all the possible outcomes or all the possibilities of a problem, or the pairing of 2 types of units as a 2-step operation. Now, what is basically the definition of multiplication rule, and how we can calculate the possibilities of any occurrence of or any problem? If an operation consists of k steps, because here we had 2 steps. In first step we have 4 possibilities, in the second step we have 3 possibilities. So in first step we have 4 possibilities, we write here 4. In the second step we have 3 possibilities, we write here 3. So the total of 12, there are total of 12 possibilities. So like this, we suppose that there are k steps. We generalize this problem now in the k steps. So So we suppose here if an operation consists of k steps, and in first step we can perform n1 ways. Means here we had in first step we had 4 ways, 4 we said n1, or you can say that at first step how many possibilities we have. At first step here we had 4 possibilities. Here we suppose that at first step we have n1 possibilities or ways. At the second step we can perform, or there are n2 ways or n2 possibilities. Regardless of how the first step was performed, we don't consider the first step, we see only the second step, and so on. At the third step we can suppose that we can perform n3 possibilities, we can perform n3 ways, and so on. At the kth step we suppose that we can perform or there are nk possibilities, regardless of how preceding steps were performed. Then the entire operation can be performed in the multiplication of all these possibilities. Means n1 into n2 into n3 into so on nk. If in first step there are n1 possibilities, in second step there are n2 possibilities, in third step there are n3 possibilities, and in kth step, any general step, 4th, 5th, it could be 4, 5, 6, 7, 8, 9, 10, anything. Then how many possibilities are there to perform this operation from starting to the ending? Basically this is the product of all these possibilities, as we had done in this example. In the first step we had 4 possibilities, in the second step we have 3 possibilities at each respect to each possibility here in the first step, so we can write 3 here, and then multiplying these possibilities we can obtain the total number of possibilities. So this is basically the multiplication rule, and it helps us to find all the possible ways to perform an operation or to solve a problem. Another application of this multiplication rules is basically if you want to choose a PIN, personal identification number, means password of your email, password of computer, password of your any file or anything you want to choose, then, and this password is of in this example we see what is the length of the password and what are the possible symbols you can choose to fix or to keep a password or a PIN, personal identification number. A typical PIN which we usually use in the bank cards, or you can use in any other place in the computer to lock any file or lock computer. A typical PIN is a sequence of any 4 symbols chosen from the 26 letters in the alphabet and the 10 digits from 0 to 9. So you have to select a PIN, a password you can say, out of 26 alphabet of English symbols. The alphabet of mathematics you can say is from 0 to 9. You can select any of letters from these to fix your PIN. How many different PINs are possible? Now we have to see how many personal identification numbers you can choose, or what are the possibilities. So for example, typical PINs are CARE, care 3387, B32B. These are the examples of PINs you can choose, and so on. You can think of forming a pin as a 4-step operation according to the multiplication rule. Now, at the first step, you choose any of the symbol out of these 26 plus 10, 36 digits. You can choose any of the first symbol. Either it could be A, B, C, X, Y, Z, U, L, M, N, O, P, Q, anything. The first symbol could be 0, 1, 2, 3, anything. Then the second, you have to choose the second symbol. It could be any symbol, any number out of 36 characters which you have fixed to choose a pin. At third step, you have to choose the third symbol. At fourth step, you have to choose the fourth symbol. Now, what are the possibilities to choose the first symbol? Because there are 26 alphabets and 10 digits, so we have a total of 36 symbols or characters, out of which we can choose the first symbol of that pin. At the second step, you have again the 36 symbols or characters, out of which you can choose the second symbol. Similarly, at the third step, you have 36 characters or symbols, out of which you can choose the third number of your pin. And at the fourth or last step, you have again the 36 possibilities, out of which you can choose the fourth number, because the repetition of number is allowed here. You can choose the first number as C, the second number again as C, the third number again as C, fourth number is again as C. There is no restriction. One symbol or one character may be repeated here 4 times, 2 times, 3 times, or it is not necessary that it repeats. You can choose 4 different numbers. For example, CARE. You can choose B32K, anything. We are discussing here only the possibilities. How many ways are there to choose a 4-digit pin? So there are at the first step there are 36 possibilities. At the second step there are 36 possibilities. At the third step and at the fourth step there are 36 possibilities. So according to the multiplication rule, you just multiply all the possibilities at first, second, third and fourth step. You just multiply these. This is basically 36 power 4, which is a very large number. So we have this number of possibilities in which we can choose a personal identification number. The pool of available symbols is given by here. The first number have 36 choices, the second number have 36, third, fourth, there are 36 choices. So this is basically the multiplication rule who gives us the solution to this problem. Now, when the pins, the personal identification number, in pins the characters cannot be repeated, means at first step if you choose some number, you cannot repeat that number on second, third and fourth step. So how many possibilities in this case? When there is no repetition, or the repetition is not allowed, the repetition of characters or symbols is not allowed to choose a pin, then how we can find the possible ways of the pins? In this case, at first step you have 36 choices, but at the second step here you don't have 36 because one number has been chosen. And at second step, one number you cannot use, whatever the number is. For example, you have chosen D, then you cannot choose D here or here or here. Then you have 35 possibilities for the second step. In the third step these two numbers at first and second step cannot be utilized at third and fourth step. So at third step you have 34 possibilities because two numbers has been used and you cannot reuse those numbers. And at the fourth step you have 33 possibilities because three numbers have already been used. So in this case the number of possible ways for choosing the pins are 36 into 35, 34 into 33. So this number, so these are the number or the possible ways in which you can choose the personal identification numbers. So this is again an application of the multiplication rules. Now we move further to the number of elements in a Cartesian product. We have already discussed what is basically the Cartesian product of finite sets, where we have discussed in the previous lectures when we had studied sets and functions. We have already discussed Cartesian product of two sets A and B, or we have also discussed the Cartesian product of a set A of a single set, means A cross A. Now we are going to discuss how we can find the number of elements in a Cartesian product of any number of sets. For example, here I have chosen an example in which we have to find first the Cartesian product of four sets A1, A2, A3 and A4. With basically these sets are finite sets because we cannot find the number of elements in a Cartesian product of infinite sets. So this is only the case we can find the number of elements in a Cartesian product of finite sets. So suppose we have four sets A1, A2, A3 and A4, with A1 has the number of elements n1, n2 has the number of elements n2, A3 has the number of elements n3 and A4 has the number of elements n4 respectively. Show that the set this A1 cross A2 cross A3 cross A4, this is not basically the cross, this is basically the Cartesian product of A1, A2, A3, A4. And we have to show that the number of elements in this Cartesian product is this n1 into n2 and into n3 into n4. So we know that in a Cartesian product of A1, A2, A3, A4 is basically this kind of Cartesian product contains ordered four tuples of the form A1, A2, A3, A4. So such type of Cartesian product basically is the ordered four tuple, because in the Cartesian product of two sets A cross B we have ordered pairs. So if you have four sets and we have to find the Cartesian product, then this kind of pair, this is not basically pair, so this is called ordered four tuple. If you have two elements then we can say ordered pair, but if you have three elements then we say that ordered three tuple. If we have four elements we say ordered four tuple. If we have five elements we say ordered five tuple, and if we have n elements we say ordered n tuple, where the first element basically belongs to the first set, second element belongs to second set, third element belongs to third set, and fourth element belongs to fourth set. So now imagine the process of constructing these ordered tuples as a four-step operation. In the first step we have to choose the first element which belongs to the first set. So how many possibilities are there to choose the first element of the four tuple? This is basically n1 because there are n1 elements in the set A1. Now step 2, how we can choose the second element of this four tuple. Basically there are n2 possibilities because the number of elements in n2 is n small, in A2 is n2. Similarly, in the third step, the third element of this four tuple, ordered four tuple, can be chosen in n3 ways. because n3 is the number of element of A3. Similarly, the fourth element of this ordered 4 tuple can be chosen in n4 ways. So by using the multiplication of rule, there are n1 ways to perform the step 1, n2 ways to perform the step 2, n3 ways to perform the step 3, and n4 to perform the step 4. So hence by multiplication rule there are n1, n2, n3 into n4 ways to perform the entire operation, and therefore we can say that the Cartesian product of a1, a2, a3, a4 basically is n1 into n2 into n3 into n4. This is what we had to prove. Now we can prove it by choosing some example. You can take two sets, A is equal to 1, 2, 3 and B is equal to AB. So Cartesian product of these two sets will contain how many elements? In first step we have 3, in first set we have 3 elements, in second step we have 2 elements. So we can, there must be 6 elements in the Cartesian product of AB. Now you can calculate what is the Cartesian product of AB. Calculate this and verify that there are only 6 elements in the Cartesian product of A cross B. This is, you can calculate and verify yourself. So we move further and we discuss circuit with 2 input signals. So how many possibilities, or you can say what are the possibilities of the outcome here. Consider the set of all circuits with 2 input signals P and Q. For each circuit, an input-output table can be constructed. Yes, this obviously we had discussed the circuits in the early lectures of this course in logic. So 2 such input-output tables may have the same values. How many distinct input-output tables can be constructed for circuits with input-output signals P and Q? So we have to calculate how many distinct, means they must not be same truth tables. So we have to calculate the number of distinct input-output tables which can be constructed for circuits with input-output signals P and Q with 2 input signals. So first of all, we can see that, and we had studied in logic, that if we have 2 input-output signals, then there are 4 possibilities of choosing input signals. Means we can write P is 1, 0, 0 and Q is 1, 0, 1, 0. So these are only the possibilities of choosing the input signals, but the output may be different, because input is same in all input-output tables, but output may be different in these truth tables. These 2 truth tables are different. Why? Because the output of this table and this table, the outputs are different, because at first place here we have 1, here we have 0, here we have 0. So if at least one of the output is different in 2 truth tables, then the 2 truth tables will be distinct or different. If all the input and outputs are same, then the truth tables are same, as we have discussed in the logic. Now, as I have told you that input signals, the possibilities of input signal are same, because here we must have 1, 1, 1, 0, 0, 1 and 0, 0. There are no other possibilities of the input signals. What we have to find here, we have to find how many distinct input-output tables can be constructed for these input signals. So we have to find the number of possibilities in outcomes to find the distinct truth tables which can be constructed by using P and Q. So at first place of the output, how many possibilities are there to choose an output? Because output is can either be 1 or 0. So there are two possibilities we can choose at the first place of the output. Similarly, at the second place of the output, how many possibilities are there to choose a particular output which can be either 0 or 1. So there are two possibilities here also. Here we have two possibilities, here we have two possibilities, here we have similarly two possibilities and two possibilities. So at first step we have two possibilities, at second step we have two possibilities, at third step we have two possibilities, at fourth step we have two possibilities. So we can systematically you can say that formulate this problem like this. We divide this this problem into 4 steps. In first step, fill in the output value for the first row, for second row, in second step, in third row, third step, and in the fourth row at the fourth step. So now we see how many possibilities are there in the first step, second step, third step, and fourth step. As we have discussed, at first step we have two possibilities, at second, at third, at fourth we have two possibilities. So there are 16 possibilities we can insert, or we can write an output. So therefore we can find 16 distinct truth tables which are basically constructed using the input signals P and Q. So this is how we can use the multiplication rule to find the possibilities in any particular problem. Now we take a rather difficult example of the multiplication rule in which the number of possibilities in each step is not evident, is not clear. Or you can say that at every step the number of possibilities we cannot calculate easily. We'll discuss this in this example or in this problem. The problem is we have to choose 3 officers. A president, a treasurer, and a secretary are to be chosen from among 4 people. We have to choose 3 people from 4 people, and we have to give them some post for in a office. For example, a president, or you can say that the director. A president, a treasurer basically which deals with the accounts of the office, and a secretary which deals, you can say that in academic routines of the to manage the files of the president or director. So we have to choose 3 these officers: president, treasurer, and a secretary from 4 people. The people are Anne, Bob, Sid, and Dan. So there are 4 people, and we have to choose 3 among these 4. We have to give first post, a post of president, treasurer, and secretary to these 3 people. But there are conditions here. Suppose that for some reasons, for various reasons, we cannot choose Anne to be the president of the office or some organization, anything. Anne cannot be chosen to be the president, and either Sid or Dan must be the secretary. So we have another condition that this Sid, or you can say Sid, CYD, and Dan, from Sid and Dan, one of these 2 people must be secretary. We cannot choose Anne and Bob as a secretary. So this is another additional condition in this problem. How many ways can the officer be chosen. So we have to find the possibilities how we can choose these officers among these from among these four people, Anne, Bob, Sid and Dan. So it is natural to try to solve this problem using multiplication rule, because we can see that this type of problems we deal in by using multiplication rule. A person might answer as follows. There are three choices for president. How many? Now first we analyze the possibilities for each post, first for a president, second for a treasurer, and then for a secretary. So how many people can be chosen for the post of president? Anne cannot be chosen because it is given in the problem that Anne cannot be the president of that office or organization. So there are three possibilities. We can choose Bob, Sid and Dan for the post of president. So there are three possibilities to choose the president. Now we see what are the, we write here there are three possibilities to choose for a president. Now how many possible ways to choose a treasurer from among these four people? Treasurer can be chosen from these four. We can choose Anne, we can choose Bob, we can choose Sid, we can choose Dan. But remember that we have already been chosen the president. So one person is fixed for the president. Now how many people are left to choose a treasurer? There are three people. There are three people which can be one of which can be chosen as a treasurer, because one we have already choose for a president. So there are again three possibilities. We can choose Anne, Bob, Sid or Dan, because Anne can be the candidate for a treasurer, but among Bob, Sid and Dan, one must be the president. So there are only three possibilities for the treasurer also. So we write it here 3 into 3. Now what is left? Secretary is left. Here we have a condition that either Sid or Dan must be the secretary. So there are only two possibilities for a secretary. So we write it here 2. So 3 into 3, 9 into 2, 18. So we have 18 possibilities to choose these three officers, president, treasurer and secretary, from among four peoples, Anne, Bob, Sid and Dan. So we have used the multiplication rule, but here in a multiplication rule you have seen that there are some other restrictions in a problem which we have to follow to choose the number of possibilities. This problem again we can show by drawing the multiplication tree, the possibility tree. At the start, to choose, the first step is to choose a president. So to choose the president we have three possibilities. Either Bob can be president, Sid can be president, Dan can be president. There are three possibilities. Now further, to choose the treasurer, if Bob is the president we can choose treasurer as Anne, Sid or Dan, because there are three possibilities for a treasurer also. If the Sid is the president, then there are two possibilities for a treasurer, because if Sid is chosen as a treasurer, then we cannot choose Dan as a treasurer, because one of Sid or Dan must be the secretary. So we cannot choose here Dan as a treasurer, because Sid we have chosen as a president, and there is a condition in the problem that either Sid or Dan must be the secretary. So if Sid is chosen here as a president, then Dan cannot be chosen as a treasurer, otherwise the condition in the problem will not be fulfilled. So here we have two possibilities, N or Bob, and then if Sid is being chosen as a president and either N or Bob has been chosen as a traitor, then Dan must be the secretary in these both cases. If Dan is the president, then we cannot use here the Sid as a traitor, because Sid must be secretary in this case, because Dan is already been chosen, so Sid must be reserved for the secretary. We can choose N or Bob as a traitor, and in both cases Sid must be secretary. In the first case, if Bob is the president and N is the traitor, then there are again two possibilities, either Sid is secretary or Dan is secretary. If Sid is chosen as a traitor, then Dan is secretary, because Dan or Sid must be the secretary. If Dan is chosen as a traitor, then Sid must be the secretary. So these are all the 18 possibilities. We can choose 3 officers from among 4 people which are given here, and we are also given 2 conditions in this problem, that N cannot be president and either Sid or Dan must be the secretary. So we have found here the number of ways, which are 18. We can choose 3 officers in 18 ways. If we reorder the steps for choosing the officers in the previous example, if we change the first step, second step and third step, there may be the possibilities may be varied. For example, if we choose in the first step the secretary, and in second step president, and in the third step traitor, then the possibilities of choosing these 3 officers will be changed, because in choosing at first step either Sid or Dan must be chosen, so we have only 2 possibilities here. At start we have 2 possibilities, either Dan or Sid must be the secretary. Then again we have 2 possibilities here, Bob or Dan, Bob or Sid. If Sid is chosen here, then Bob can be president, Dan can be president, because according to the condition in the question, N cannot be president. So we have only 2 possibilities here. So 2 here and 2 here and 2 here. So we have 8 possibilities, because at first step we have 2 possibilities here. At first step we have 2 possibilities. At second step we have 2 possibilities. At third step we have 2 possibilities. In each case, here we have 2, here we have 2, here we have 2, so here we have 2. So at first step we have 2 possibilities, at second step we have 2 possibilities, at third step we have 2 possibilities. So we have 8 possibilities if we reorder the selection of the officers by choosing first secretary, second president and third traitor. Similarly, if you vary if you again reorder the selection steps, for example, first you choose the traitor, second president, third secretary, the possibilities may vary in this case also. You can try it yourself. I have discussed here 2 possibilities, 2 cases. In the first possibility we have chosen president first, then traitor, then secretary. In the second possibility we have chosen first secretary, then president, then traitor. You can vary this process of selection, and then you can see that the number of possibilities may vary. Next is the permutations. So what is permutation? A permutation of a set of objects means if we have a set of 3 elements, for example A, B, C, if we have this set, a permutation of a set of objects is an ordering of the objects in a row. Means how many ways are there such that we can place or order the objects in the given set. This, a permutation of a set of objects, is an ordering of the objects in a row. For example, if we have a set of elements A, B, C, it has 6 permutations, means there are 6 ways in which we can arrange the objects or elements of this set. For example, the first arrangement is ABC, the second is ACB, the third is CBA, BAC, BCA, or CAB. So these are all the possible arrangements of the elements of this set. So this is basically called the permutations. If you have a set of 2 elements, for example 1, 2, then how many ways are there we can arrange or we can order these 2 elements of this set? Then we have 2 ways. We can write 1, 2 or 2, 1. So there are 2 ways in which we can arrange the elements of this set. If we have a set of 3 elements, then we have 6 permutations. You can say 6 ways in which we can arrange we can list these 3 elements. For example, we can write ABC, ABC, ACB, CBA, these are written here, BAC, BCA, CAB. Now think here whether there is another way you can write these 3 elements in some different order which is not written here in 6 possibilities. So there is no other way we can arrange or order these 3 elements. So these are basically the permutations of the elements of this set. If you have 3 elements, there are 6 permutations or 6 possible ways in which we can order these 3 elements. So such type of arrangements is basically called the permutations. So what is the application of the permutations? We'll see in examples in the next slides. So what is the application of permutation? In general, if a given set have n objects, how many permutations does the set have? Imagine forming a permutation as an n-step operation. Basically, in a permutation, in the first place, if one letter has been used, then this letter cannot be repeated. For example, at first place, if you have chosen A, then we cannot write AAC. All the letters must be used in an arrangement or in an order. ABC. We cannot write ABB or AAC or ACC. So all the letters must be used in the permutations. So at first step, how many possibilities are there for a letter to be chosen? We have 3 possibilities. A, we can choose either A, or B or C. And what is the possibilities at the second step? 2, because one letter has been used. Now there are 2 possibilities. And what is the possibility at third step? This is 1. So 3 into 2 into 1, this is basically 6. So we can choose 6. We can arrange these 3 letters in 6 possible ways. So if you are given a set of n objects, then how many permutations does this set have? This is basically the definition. For any integer n with n greater than or equal to 1, the number of permutations of set with n elements is n factorial. N factorial is basically, we have discussed it in previous lectures. N factorial is basically n into n minus 1 into n minus 2 and so on into 3 into 2 into 1. So this is what? If n is 3, then 3 to 1 is basically what? This is 3 factorial. 3 factorial is 6. So the number of permutations of a set with n elements is basically n factorial. Now permutations, for example, permutations of the letter in a word. How many ways can the letter in the word computer be arranged in a row? So we count the elements here 1 2 3 4 5 6 7 8. So how many ways we can arrange the letters? Means C O M P U T E R. These are 8 letters in a computer. Then how many ways can the letters in the word computer be arranged in a row? So there are 8 letters, so we can say that 8 factorial, which is basically what 8 factorial is 40,320. So there are 40,320 possible ways we can write the letters COMPUTER in be arranged in a row. So how many ways can the letter in the word computer be arranged if the letter CO is fixed? Must be remain next to each other in order as a unit. So this we have to use as one unit. So then how many letters are there? 1 2 3 4 5 6 7. So if CO is fixed, then there are 7 letters. So in this case we have 7 factorial, which is 5040 possible ways we can arrange the letters, alphabets, you can say that MPUTER CO we can write in different ways. So this is basically the permutation, and we'll discuss it further in the next lecture. I think for today it's enough. And what we have studied today is basically we have started the multiplication rule, countings. We have counting rules we have started today, and I have given you a little introduction of the counting rules, and then we have studied multiplication rule and the applications of multiplication rule, where we can use the multiplication rule to find the number of possible ways, and then we have started today the permutation. In the next lecture we shall discuss the permutation of objects around a circle and a property of the permutation. So till the next lecture, Allah Hafiz.